Okay, so this is the intro. I do about statistics previously, maybe perhaps in your high school or maybe just from daily life, actually, because statistics is probably used every single day in normal conditions. So I'm going to start with an intro. What is statistics? So instead of me talking about this in detail, because you already should have read or sorry, seen the video on Scale, right? I'm going to give this lecture assuming that you've already seen the introductory video on Scale. So what is statistics? I'm going to get someone more knowledgeable than me to talk about that. Give me a second. Recording. So the second question is, what is probability? And this all depends on context. So these two blobs of color, if I were to ask you, what's the probability that these colors are water? Maybe since what you know, your knowledge base is a water, C is probably blue, you would say yes to the left one, but no to the right one. But in fact, both of these are snippets of images of water. So everything is dependent on what information you do have. You are just trying to infer something about what you don't have, and everything is dependent on context. I will not go through the formal definitions as you have already seen them on the video, but too long didn't read. These are the definitions of statistics and probability. So since I assume that all of you are fluent in English, you probably can already deduce what we're going to learn when we talk about statistics and maybe what we're going to learn when we talk about the probability. Like, I bet it would be easy for you if I were to ask you, what's the probability of it snowing today in Jakarta? You can probably use the knowledge base you have and you could probably answer me. So without you even realizing it, you've already computed a probability in your head. So in order for us to define it a little bit more formally, a little bit more academically, we do need to know some basic concepts. So at the end of the video that I asked you to watch on Scale, I introduced some basic concepts. There's the data and data set concept, population and sample, parameters and statistics, and so forth. But we did not go into detail on the video, and I'm going to try to cover them right now. So these are some definitions. Data and data set. What's the difference? Data is a plural, data is a plural form of datum. Datum is a singular form, and a data set is a collection of individual measurements that you took. Like, for example, I took a measurement of the heights of everyone in this class. The entirety would be called a data set. However, these are the definitions that are formally defined, especially in the book that I told you I used as my reference. However, in many popular articles, these words have been used interchangeably these days. So if I were you, I wouldn't worry that much about the definition as long as you are aware of the formal definitions here. Second is population and sample. So if we use the analogy of the fishbowl that we were talking about in the introduction in the video that I showed you earlier, what was given to the audience was a sample, was a small portion of whatever it is that we are intending to study, while the population is the total collection of the elements being studied. Like, for example, if I wanted to study about the average GPA of UI students, obviously, I would not be able to ask every single UI student. If I wanted to ask what's relevant these days, like what is the amount of the duration of time you spend outside of your house in these COVID times, I would not be able to ask every single Indonesian. So in order to understand something about the entire population, we often need to take a smaller sample to study, to make it feasible, to make it doable, and then we can we can infer something about the entire population. How do we do that? Obviously, we need to do something called sampling, but not just for any type of sampling, statistical sampling. There are 5 basic sampling techniques that we will be covering in this course. Obviously, these are not the only sampling methods that can be used, but these are the most commonly used and acknowledged. The first one is random sampling. As its name says, it is a pick a name out of the hat technique, and you can facilitate that using random number tables, or maybe if you guys have seen like how influencers check their comments, there's also a random generator to select comments to get to choose a winner of a giveaway. All of those techniques fall under the random sampling technique. So from a group of options, a group of elements, you just choose at random X many people. Obviously, this is not really random. It's actually pseudo-random, but that is another argument that we can say for another day. The next is systematic sampling. So all data has a number or an order, and we take every n data. Like for example, here I put everyone in an order, and I took every 4th person. Like here in my window, in my Zoom window, I could take every 4th person. So I could go from the start and I will go, oh, there's Bill Huda, and then there's Indira, and then there's Ainul, and so forth. So every 4th person in my list of participants in this Zoom class. There's also stratified sampling, in which we predefine the whole population into subgroups or strata. So I can group people based on their age, perhaps on their education level, or so forth. And then after I divide them into their groups, then I do random sampling in each strata. Like for example, if I were to do stratified sampling at Fasilkom, I could divide students into the 2021 cohort, 2020 cohort, and so forth. And then I can random sampling from each cohort. Lastly, these are also cluster. We can also do cluster sampling. So we also divide the data into clusters or groups, just like what we did before. But if before we did random sampling within each group, here we use random sampling to choose groups. So here I already have some groups, and I choose at random group 1, group 2, and group 6. So the groups will then be used in their entirety. So please differentiate between the stratified and cluster sampling methods. And lastly, probably the one that is most often used, it is convenience sampling. So like, for example, you could just send out the Google form to anyone in your circle, but then you will only get usually a narrower variation of people, because obviously your friend group is probably homogeneous or people that you know. This also falls into the same category as if you were to wait in front of Fasilkom and give out a survey to every single person that goes by you, because most likely those are Fasilkom students. That means that your population is only Fasilkom students and is likely biased. So these 5 sampling methods can be used. All of them are valid. All of them are acknowledged. And just keep in mind that all of them are different in how you conduct them. And this is just one example as to how you can conduct these 5 different methods in the same for the same set of data. So we needed some sampling methods in order to extract a sample from the population. So while we're considering the population and the sample, we can also consider parameters and statistics. Please remember that a parameter is to a population as a statistic is to a sample. That means if I say the mean of 100 UE students GPA is 3.4, for example, I'm talking about a statistic that I measured from the sample that I have. But if I were to say something like the mean of the GPA of all UI students, that means I'm talking about a parameter, because I'm talking about the parameter that is owned, or that is a characteristic of the entire population of UI students. So say I want to conduct my research now. So I have a population that I would like to study, but obviously I can't study the entirety of it. So I have to do sampling to get a small sample. And now I would like to measure my data. What is it that I'm measuring? Maybe I'm measuring GPA. Maybe I'm measuring height. Maybe I'm measuring the duration of time spent outside their house in COVID times. So all of these measurements that I'm taking for the collection of my data, these are called, that's my data that I'm collecting on the variables. And how do I get them? I need to measure them. So in order to measure them, I need to put it on some sort of rule, some sort of scale, because as you see, not all measurements are the same. Like I could measure height using centimeters. I could measure height using feet. Or I could also say that that person is tall and this person is not. So how precise do you need to go? Obviously, it depends on what you're trying to do. But it is an important factor as to how much info, how much richness of information you have, how crucial your decision that you're going to make from the data is. Then you must know that you need to adjust your scale of measurement based on your needs. So overall, there are 4 scales of measurement: the nominal scale, ordinal scale, interval scale, and ratio scale. All of these are ordered on a hierarchy based on their precision. That means in this list, the nominal scale is the least precise and the ratio scale is the most precise. Let's look at some properties of each of these scales. So the first scale is the nominal scale. This is the least precise. That means that, but the only criteria that you need to have is that the data categories are mutually exclusive. That means if I put one person in one category, he cannot fill in another category. And these categories have no logical order, so I do not have one over the other. Some samples here are gender, color of eyes, blood type, favorite candy, favorite flavor of juice, and so forth. So the only thing that I know is that every measurement I take is mutually exclusive. So if I were to ask Anastasia her gender, and we would only categorize her as female, for example, and we know that these 2 gender classes are mutually exclusive. But there are no logical order. So if I have an option of male and female, there is no order as to which one is more or which one is less. So the only property that I have here is mutually exclusiveness, mutual exclusiveness, sorry. So next, I have the ordinal scale. Once again, they are mutually exclusive. So I already know that I will have the same ME property on this scale. But differing from the previous nominal scale, the ordinal scale has some order to it. So for example, is the grade of that you will receive at the end of this semester: A, B, C, and D. These are mutually exclusive. Obviously, you cannot get a C and a D, but you also know that A is better than B, B is better than C, and so forth. However, the differences in the amount of measured statistics may not be discernible in the sense that they may not be standard. We cannot we cannot say with certainty that A minus B equals D minus E. So it's not the same numeric scale that we would say used with numbers. So in addition to the ME that we already had, now we also have the LO property, which is logical order. Okay, so for the next scale, so sorry for the animation. I guess it was a little bit messed up. I apologize. But now we already have the ME and the LO properties. Now we are going on to the interval scale and we're going to add on one more property. So first they're mutually exclusive and then they have logical order. And now we can determine an equal difference. So if previously we could not say with certainty that the difference between A and B is the same with D and E, but now there is an equal difference. For example, if I'm talking about temperature, I can measure with certainty the difference between 23 degrees Celsius and 20 degrees Celsius is the same between 197 and so forth. So here we have three new properties. So the mutually exclusive one, I brought it from before. Logical order, I also brought it from before. And now I'm adding one more property, which is equal differences. But please note that there's one additional thing here. There, point 0 is just another point on the scale. So the number 0 does not indicate an absence of measurement, but it is just another point on the scale. It's just one tick on the line. So that's why a really good example is temperature, because the temperature of 0 degrees Celsius does not mean an absence of temperature. It just means that it is 0 on the scale. Finally, we have the ratio scale, which is the most precise measurement scale. Once again, I apologize, the animation has not caught up with me, but we still have the mutually exclusive property, and we have the logical order property. We also have the equal differences property that we brought from before. However, one additional property that we have is that the point 0 is no longer just a tick on the scale, but it reflects an absence of characteristics. Like, for example, weight and height. So when you're talking about temperature, 0 is just another temperature. But when you say someone's height is 0 centimeters or his weight is 0 kilograms, that means that it doesn't exist. It's an absence of characteristics. But you can also say that 50 kilos is twice as heavy as 25. However, 50 is not twice as hot as 25 degrees Celsius. So here you can see that when we started from the nominal scale, we started with the mutually exclusive property, which is brought down to the most precise scale as well. Then we have the logical order, which does not apply to the nominal scale, but does apply to all the ones underneath it. Then we have the equal distance that only applies to the interval and ratio scale. And we have the final criteria, 0 of absence, which is only applicable to the ratio scale. So as I mentioned before, when we're talking about measuring something, we are measuring something to be assigned to a variable. So each characteristic or each attribute that we are measuring can take on different values for different members of the group. Like, for example, when I say the variable is a height, that means that this height can be a different value for each sample that I study. So my height might be X centimeters. Sorry, I'm not going to disclose that. Someone else could have Y centimeters and so forth. But the type of values that I assign to these variables can differ, and thus I can define different types of variables. The first type is quantitative versus qualitative variable. Obviously, when I talk about quantitative, that means it's a quantifiable variable. I can quantify it with some number. So we can either measure that on the nominal or ordinal scale, and measurement consists of, oops, I think I mixed up these definitions. So this should be on the right-hand side, and the number 1 should be on the right-hand side. Let's correct that before I mess this up further. Give me a sec. So the quantitative variable is described by a number, and the qualitative variable is categories, more or less. So if I were to ask you what your favorite K-pop band is, that would probably be a qualitative variable because I cannot put a number to it. Next, we can also define a discrete and continuous variable. Like when I'm talking about a discrete and continuous, a lot of the times I've had students talk to me, tell me what discrete means to them. They would usually use this gesture. So discrete variables are like this. Like I have one person, two people, three people, four people coming to the hospital. It's not possible to have 2.5 people. Whereas for a continuous variable, the value can have any value of a numeric value on the line, like weight, height, and so forth. It is possible to have a weight of 57.6 kilograms. And next we have the term distribution. So the distribution is a summary. I will actually go into more detail in the next descriptive statistics course, so I won't go into that much detail. But when I'm computing frequencies, like here, when I talk about there are how many people getting a starting salary of 47. So there's 4 people. How many people getting a starting salary of 48? There's maybe 1 person. So this distribution is called the distribution. So how I plot this frequency between different values, this can be plotted using a distribution or distribution graph. So in this case, we have a discrete variable that shows a distribution shape like that, and so forth. We will look into different types of distributions in later classes. So up until now, we have learned about some terminologies or important definitions that are pertinent to the statistics part of this course. Now we're going to move on to the probability part of this course. So when I'm talking about sample space and events, when I'm talking about probability, I'm talking about an experiment. That means I don't know what's going to happen when I do it. So the outcome could be anything. Like for example, when I'm talking about rolling a die or tossing a coin, I don't know what's going to happen when I do that. So when I throw my dice, for example, that means my sample space is everything that could have happened. Like, so in the case of rolling a die, that means that I could get numbers 1, 2, 3, 4, 5, or 6 from the dice roll that I did. However, what actually happened is the event. Like, for example, if I'm talking about this, E is the event in which the dice gives me an even number. That means this is the event. It is a subset of what could have happened. So when you're talking about everything that could happen is the entire sample space. But when we're talking about the subset of what you want to consider or what you want to look at what's happening, then we're talking about the event. And as a rule, we are going to use this basic probability theory in order for us to express probability. So you might have heard that, like if I say, like, what's the probability for it to rain today? People could answer, it's a 80% chance, for example. So it can be orally described as a percentage, but a percentage is actually anything over 100, right? So it is actually just a decimal. It is when we're talking about an event E that could happen, considering the entire possibilities of a sample space S, then we can determine as a rule that the probability of E occurring must be between 0 and 1. So if you want to look into more depth, there are theories, there are works, mathematical, theoretical research that says that probabilities can be defined up to over 1. like a 1.2, for example. But this is not what we are going to consider in this course. In this course, we are going to consider the basic probability theory, in which all probabilities will fall between 0 and 1. So those are the terminologies that you will need to know in the duration, for the duration of this course. Does anyone have any questions?